Now our next topic is shortest distance between two lines. Before that, we discuss about the skew lines. What is skew lines? What is skew lines? Skew lines mean two lines which are neither parallel nor intersecting. Two lines which are neither parallel nor intersecting. That means here suppose two lines are given. Space, these two lines are parallel. In this form, these two lines are intersecting. But in this way, ഈ രീതിയിൽ നമ്മൾ represent ചെയ്താൽ these two lines are neither parallel and nor intersecting. Okay. In this case, these lines makes a distance. ഇതുപോലെ ഇതുവരെയുള്ള ഒരു ഡിസ്റ്റൻസ് ആണ് ഈ ലൈൻസ് തമ്മിലുള്ള ഏറ്റവും ഷോർട്ടസ്റ്റ് ആയിട്ടുള്ള ഡിസ്റ്റൻസ്. How to find the shortest distance between the two lines? Here we consider two lines. First line is vector r is equal to vector a1 plus lambda into vector m1, and second line is vector r is equal to vector a2 plus mu into m2 are two lines. Here first line is passing through the point is a1 and parallel vector is m1, because this and the second line is passing through the point is a2 and parallel vector is m2. Here vector r is a general point, so its position vector is commonly represented as vector r. Okay, P is general point and this position vector is generally represented as vector r. But these are different. M1 and M2 are they are parallel vector, but these two lines are not parallel. Okay. Now the distance we have, okay, proof is not very important. So we by heart the formula. It's a very important section. Shortest distance between two lines. SD is equal to shortest distance between two lines. SD is equal to modulus of formula is A2 minus A1 dot M1 cross M2 divided by modulus of M1 cross M2. Formula is shortest distance between two lines. Formula is A2 minus A1 modulus of A2 minus A1 dot M1 cross M2 divided by modulus of M1 cross M2. First of all, you by heart this formula. Using this formula, now we do our first question. Our first question is find the shortest distance between vector r is equal to I plus 2j plus 3k plus lambda into I minus 3j plus 2k and vector r is equal to 4i plus 5j plus 6k plus mu into 2i plus 3j plus k. Find the shortest distance between two lines. Vector r is equal to I plus 2j plus 3k plus lambda into I minus 3j plus 2k and vector r equal to 4i plus 5j plus 6k plus mu into 2i plus 3j plus k. First of all, you write a1, a2, m1, m2. Okay. Here given line vector a1 means first line passing points are I plus 2j plus 3k. a2 means second line passing point is 4i plus 5j plus 6k. Then m1, vector m1 corresponding vector is I minus 3j plus 2k and m2 corresponding vector is 2i plus 3j plus k. Okay. Now our formula SD is equal to, you know already formula is modulus of a2 minus a1 dot m1 cross m2 the whole divided by modulus of m1 cross m2. Here first of all we find a2 minus a1. Vector a2 minus vector a1 is equal to a2 minus a1, that is 4i minus i 3i, 5j minus 2j 3j, 6k minus 3k 3k. Then you find b1 cross b2. b1 cross b2 is equal to determinant I j k. Here sorry b1 m1 sorry m1 cross m2. b1 and some insert test we follow b1 cross b2. There is no problem. You take m1 cross m2. Here m1 correspond to coefficients are 1 minus 3 2. m2 coefficient are 2 3 1 and this determinant value is I into minus 3 minus 6 minus j into 1 minus 4 plus k into 3 plus 6 is equal to, we get answer minus 9i plus 3j plus 9k. Okay, now modulus of m1 cross m2 is equal to square root of 81 plus 9 plus 81 is equal to, we get answer root 171. Then a2 minus a1 dot m1 cross m2, a2 minus a1 dot m1 cross m2, a2 minus a1 dot m1 cross m2. Here a2 minus a1 is minus 9i, sorry, a2 minus a1 is also m1 cross m2 is a2 minus a1 is 3i plus 3j plus 3k dot m1 cross m2 correspond to minus 9i plus 3j plus 9k. Now you take the dot product, we get answer minus 27 plus 9 plus 27 is equal to, we get answer 9. Substituting the value, our equation number 1, that means our SD is equal to short distance formula is modulus of a2 minus a1 dot m1 cross m2 correspond to 9 divided by its modulus value is root 171 is equal to, finally we write 9 divided by root of 171. That's all. It's also expressed as 171 as 9 into 19. We get answer 3 divided by root of 19 is a better answer. Okay, we'll do one more question based on this formula. The next question is, find the shortest distance between x plus 1 divided by 7 equal to y plus 1 divided by minus 6 equal to z plus 1 divided by 1, and our second line is x minus 3 divided by 1 equal to y minus 5 divided by minus 2 equal to z minus 7 divided by 1. Okay, first of all you write vector a1, a2, m1 and m2. Here given vector a1, that means our line comparing with the Cartesian equation x minus x1 divided by a equal to y minus y1 by b equal to z minus z by c. Here x and y1 is represent a passing point. Here passing point is minus 1 minus 1 minus 1, that is minus 1 into I minus 1 into j minus 1 into k. Then second line passing point is 3 5 7, that is 3i plus 5j plus 7k, because you comparing with x minus x1 y minus y1 z minus 1. Here x and y1 is z2, s2 y2 z2 represent 3 5 7. Then m1 is first line parallel vector, that is 7i, direct ratio 7 minus 61, that is 7i minus 6j plus 1 into k. Then m2 means second line parallel direct ratios are 1 minus 2 1, that is 1i minus 2j plus 1 into k. Okay, now we first of all, you know the formula SD is equal to modulus of a2 minus a1 dot m1 cross m2 divided by modulus of m1 cross m2. That is equation number 1. First we find a2 minus a1 is equal to 3i minus of minus I, that is 4i, 5j minus of minus j plus 6j, 7 minus of minus 1 plus 8k. Then m1 cross m2 is equal to determinant I, j, k. Here m1 positions are 7 minus 6 1, 1 minus 2 1, and its determinant value is I into minus 6 plus 2, that is minus 4, minus j into 7 minus 1 is 6 plus k into minus 12 sorry, minus 14 plus 6, minus 14 plus 6, we get answer. Minus 8 is equal to minus 4i minus 6 into j minus 8k. Now, we find a2 minus a1 dot m1 cross m2. a2 minus a1 dot m1 cross m2 is equal to, a2 minus a1 is 4i plus 6 into j plus 8k dot minus 4i minus 6j minus 8k, and dot product become minus 16 minus 36 minus 64 equal to minus 116, because 36 plus 64 is 116 minus 116. Then modulus of m1 cross m2 is equal to square root of 16 plus 36 plus 64 is, again we get answer root 116. Substituting equation number 1, and therefore shortest distance is equal to modulus of minus 116 by root 116 is equal to 116 by root 116. This 116 can be written as root of 116 the whole square by root 116. Here root 116 cancel, and therefore we get answer root of 116. It's very important problem. It's already a 4 mark, but now it's a 3 or 5 mark section. So do 5 or 6 problems for getting a better idea. Our last topic of the straight line is distance between two parallel lines. Distance between two parallel lines. Distance between two parallel lines. Okay, and this proof is not necessary, so by heart the formula. A line vector r is equal to a1 plus lambda into m, and second line is r is equal to a2 plus mu into m. Here the lines parallel vectors are same area. These two lines are parallel and their passing points are different, because these two lines passing points are different. Here is a first point position vector vector a1, second point position vector a2. This line is parallel to a common pair vector, that is vector m. Okay, it is the distance between them formula is very simple. D is equal to, distance between them formula D is equal to modulus of a2 minus a1 cross vector m divided by mod m. Okay, a2 minus a1 cross dot product is commutative, but cross product is not commutative, so this is by heart actually a formula modulus of a2 minus a1 cross vector m divided by modulus of m. Okay, I will do one question based on this formula. Find the distance between the lines. Find the distance between the line vector r is equal to 3i plus 2j minus 4k plus lambda into I plus 2j plus 2k, and second line is vector r is equal to 5i plus 0j minus 2k plus mu into I plus 2j plus 2k. Already this clearly is a parallel lines. Formula for distance between two parallel lines. First of all, you write vector a1. Vector a1 is 3i plus 2j minus 4k. Then vector a2, 5i plus 0j minus 2k, and vector m corresponding to I plus 2j plus 2k. Formula D is equal to modulus of a2 minus a1 cross vector m divided by mod m. That's equation number 1. Now we find a2 minus a1. Here a2 minus a1 is equal to, we get answer 5i minus 3i, that is 2i, 0j minus 2k minus 2j minus 2k minus 1 minus 4, that is plus 2k. Okay, that is a2 minus a1. Now we find a2 minus a1 cross vector m equal to determinant I, j, k. Here a2 minus an coefficient are 2 minus 2, 2. And vector m coefficient is, that is parallel vector is already given 1, 2, 2. Now we find the determinant value I into minus 2 into 2 minus 4 minus 4, that is minus 8, minus j into 4 minus 2 is 2, plus k into 4 plus 2 is 6, that is equal to minus 8 minus 2j plus 6 into k, that is a2 minus 1 cross m is equal to, we get answer minus 8i minus 2j plus 6k. Now we find the modulus of a2 minus a1 cross m is equal to square root of 64 plus 4 plus 36 equal to, we get answer root 104. Then mod m is also, mod m is square root of 1 plus 4 plus 4 is equal to, we get answer 3. Okay, and therefore you substituting equation number 1, we get answer distance between them for the modulus of L is root of 104, numerator part is root 104 divided by 3. That's all. That is the distance between two parallel lines. Okay. Now next topic, in our next video we will start our next section. That's all. Bye.